Okay, hello every student. I think a long time never live my video already. So today I will live my video for the Form 4. Form 4 Physics, formative practice for the 2 point, I think 2.4 lah. 2.4 is until 2.6. So we will discuss for some question here. Maybe just a short of the video lah. So hopefully the student you can follow me and also hope you can share my video. Okay, let me to share my screen first. Okay. Okay, so from here I share my screen already. So from here I just want to discuss just a short of the exercise. So hopefully you all can can see my screen here. Okay, so from here, okay, first one, there's a formative practice. There's a 2.4 until 2.6. Okay, let's see what is a 2.4. I think every student you already done. So from here, you can check your answer. Okay, first one, you can see the explanation. First one, they call you to explain the concept of the inertia. I think everybody will know what means of concept inertia. Okay, hi, Tivesh Kumar. Okay, so from here we go through what is the inertia first. Inertia, everybody to know, there's a one of the situation. That means the object, when they are moving or they are rest, they will cease to change the motion. Is it this one is a chapter 2.4, the first topic we learn for inertia. Okay, let's see the following question. Okay, from here you can see the first one they call you to explain. Explain the concept of inertia. So from here I will show the explanation for the concept inertia. I think every student you learn before. This one 2.4 when you just enter, your teacher will start to explain for you what is the definition of the inertia. Okay, what is that? Okay, inertia is a tendency of an object, okay, to remain rest. That means the object, they want remain rest, or the object is moving, okay, to continue its motion in a straight line at a uniform velocity. Tendency means the meaning is they do want to change the motion. Either the motion is rest, either the motion is moving. That means you tendency to change the situation. Okay, so this one we call it inertia. Okay, next we see the question. Okay, Brian wishes to pull a tablecloth. Okay, without toppling the things on the top of the tablecloth. Okay, how can the Brian can do it? So from here, this one they're talking about you pull the tablecloth. Okay, got something that's on the table, then you go to pull it. So you need to explain to Brian how you need to pull it and also explain your reason why you need to do like this. So normally the inertia is happen in a short moment. So when you pull, you must very fast. Okay, you very fast means the object on the table, they are tendency to change the motion. The motion is what when starting their rest, that means they do want to change them at the situation, the original state, that means stationary. So that's why they will continuous on the table. They do want to move together with the tablecloth. So that means if you pull slowly, that means a longer time already. If longer time, that means the toppling on the table, there are more enough time to change the situation. So that's why we're talking about inertia must happen in a short moment. Okay, let's see the explanation. Okay, first one they say he must pull the tablecloth quickly. Okay, important you must say quickly. Okay, reason they want to prevent the object on the top of the table follow the movement of the tablecloth. Okay, so from here the object on the table resists to change its initial state. The initial state is what? Stationary. So this one is a reason why they never follow the tablecloth and move together. Okay, so from here, this one is a question number two. Then we continue to the second one. Okay, number three, you need to study the following statement. Okay, we got three statements. Okay, let's see the first one. The object can continue moving only if a force acting to them. So that means this one meaning is the object they want to continue to move if they got force. If no force, they cannot continue to move. So this one meaning just like the opposite inertia. The inertia means if I want to moving, I want continue to moving unless you stop me, is it? So this one sentence, the statement one, actually there's an opposite inertia. They say what? I only can move if got force acting to me. This one just talking about force, not inertia. Inertia is I'm moving, then I want continue to move. If I stationary, I want continue stationary. So statement one is out from the inertia. Okay, number two, rocket in the outer space can move without any engine thrust. Engine thrust means a force to make the rocket to move. So they're talking about when the rocket go to outer space, they can move. Okay, don't have any force to make it, but after that, the rocket can be moved. Means before the rocket launch, they are forced to help the rocket to move. They got momentum. Until they go to outer space, they don't have any force already, but the rocket still continue to move. So this one, there's a meaning from the statement number two. Okay, then we go to number three. A force is required to change the state of motion of the object. So that means the object, you want it to change the motion, so you must apply the force. So this one also talking about the force. So from here, the A, they ask you which one statement can be explained by using Newton's first law of motion. Okay, Newton first law of motion. Okay, now we go through and see what's the Newton first law of motion. Newton first law of motion, that means the reaction. That means the object, they want continue the motion, either moving in straight line or they want continue the motion is stationary unless they got extra force to force the object to move. Okay, that one is Newton first law. Almost same like the inertia, is it? Okay, so from here they want you to choose statement one, two, three. Which one is the inertia? So from here I see the Tivesh Kumar give me the answer is a statement three. Okay, we go through the statement three. What's the meaning? Statement three means force is required to change the state of motion of the object. Okay, that means this one just talking about the force applied to the object, then the object move. Okay, they never say about the object is stationary, they want to continue stationary. Okay, all the object is moving. Okay, they can change the object moving become stop. Okay, so three actually is not related with the inertia. Okay, from here the answer should be number two. Rocket in the outer space can move without any engine thrust. That means don't have any force to force it, but the rocket still can move. That means the rocket is continuous to move. Okay, so from here we're going to see the answer. Okay, 3A, there's a statement 2. Okay, the rocket in the outer space, important we know outer space, we don't have any air resistance. So that means don't have any force to resist the rocket to moving. So the rocket can continue to move. Okay, don't have any force to force it. So from here we find it. The answer should be A, then we do some explanation. So the explanation is the rocket continue to move due to its inertia. Okay, they cannot stop immediately. The due to its inertia continue to move and without any external force, that means the air resistance in the outer space acting on it. Okay, so from here, this one we're talking about inertia. Okay, so from here, this one, the answer for number two, rocket in the outer space, they can continue to move without any engine thrust. Okay, then we go to formative 2.5. There's a momentum. Okay, let's see what means by momentum of conservation of momentum. So this one is a principle. So we're talking about a principle. Principle is talking about total momentum before collision must equal total momentum after collision. So this is a definition for the principle. So we just write, Okay, they asked about meaning. What means by momentum and conservation momentum? So we answer the first one first. Okay, what means of momentum? Momentum, we just transfer from the original formula, become the words. So then should be product Z. Okay, there's momentum is a product of the mass and also velocity. So this one is a definition. Okay, number two, principle. Principle of conservation momentum before collision must equal total momentum after collision. So remember the keyword is total momentum. Okay, we never say the personal momentum. We're talking about total momentum. Okay, momentum is the product of the force and velocity. Force and velocity, I think there's a little bit problem. We never mentioned there's a force and velocity. There's a mass and velocity. Okay, correction, mass and velocity. Then remember the principal conservation of momentum. They were talking about total momentum, total collision. Okay, before collision and also after collision. Then behind you need to add no external force. Okay, that means the whole system we don't have any force to acting to the system. Okay, then we go to number two. There's a calculation. Okay, calculation, that means when we start to do, we must read the question. Number two, you need to write the info. Okay, let's see the first one. The lorry, the mass is 1000 kg. Move at the velocity 5. That means 5 is the initial velocity. Okay, it collide with the car of the mass 800 kg. So now you got lorry, then you got car. Car is another mass. Moving with the velocity 2. So this one is the initial velocity for the car. Okay, in the same direction. That means in the same direction means the velocity we can put in the same direction, we put positive. Okay, now if the lorry they move at the velocity 3.4 in same direction after collision. Means after collision the lorry is still moving. Okay, moving with the velocity 3.4. So this one we can call it as a final velocity for the lorry. Okay, in the same direction as you before that. So before that, if go to the right, finally they also go to the right hand side. Okay, now they want you to calculate the velocity of the car. Okay, the car, how to move, we do know. They go to left or go to right, we do know. We must depends the answer. If we get the answer is positive, means they follow the lorry direction, go to the right. If they get the answer is negative, means the car finally they will move in opposite direction. Okay, now we write all the info first. Okay, this one is all the info. First one, we label lorry is M1, 1000 kg. Okay, they're moving U1, 5 ms negative 1. Okay, M2 is a car, 800 kg. Then the initial velocity is a 2. Okay, after that, one more info, there's a here, 3.4. Okay, after collision, the lorry still got moved. This one we call V1. Okay, let's see the calculation. Okay, the situation like this. You can see the diagram. Okay, a lorry. Okay, the lorry is moving. Okay, go in front. Okay, this one velocity is U1, 5. Okay, then the car is follow. There's a 2. Okay, move in same direction. This one we call before collision. Okay, after collision, they're still separate because the question they mentioned the lorry velocity, but they never mentioned the car velocity. They call you to find is it means the final after collision they got two velocity. When they got two velocity, understood both object is separate. Okay, if separate, this one we call it as a elastic collision. Okay, so you must think about elastic collision. What is the formula? Okay, now we go to show what is the formula. Okay, this one is a final. Okay, so from here they ask you what is the velocity of the car after collision. So we're just using the principle lah. Okay, elastic collision. Okay, this one is the formula for the principle of conservation momentum for elastic collision. So we just apply all the info in after you find what is the V2. Okay, Divesh give me answer 4 ms negative 1. So we're going to check is it the answer correct or not. Okay, so this one is all I put in. Then finally I'm going to find the V2. Okay, give all the things 6,600. You need to minus 3,400. Okay, after that divide by 800. So we find the answer. Yeah, correct. Okay, Divesh correct. There's a 4 ms negative 1. Okay, so from here we go through the following question. Okay, the following already go to 2.6. So we discuss about 2.6. There's a force. Okay, force act on a body mass 5 kg. Okay, the body mass is 5 kg. Now, if the body that accelerate uniform from 2 to 8, so understood 2 is the initial, 8 is a final. Okay, determine the value of the F. So from here, F, we just got one formula. F equal MA, is it? So from here, I think this one question for English version, they got lost the time. They never mentioned the time. Because I go to check the BM version. Okay, BM version for the physics, they got mentioned the time. So you help me to add in 2 seconds. Okay, the question, they lost about the time. If it lost about the time, that means we cannot do any calculation. Okay, now we know the time already. That means we can do the calculation to find the acceleration first. Okay, after you find acceleration, that means we can apply F equal ma to find what is the F. Is it? That's a simple. So from here, we find the acceleration first. Okay, we do question A. Okay, this one is an info. 5 kilograms initial, then this one final. Then the time taken is 2 seconds. So they ask you about the force. So we find the acceleration first. Okay, F equal ma, you must using the A. But now the question don't have A. So we find out what is the A first. Okay, so from here, phi is a mass. So we apply the phi. Okay, acceleration, actually how to find it? Remember acceleration is the final minus initial. So final 8 minus 2 divided by 2. Okay, so from here, okay, I get the answer from T-Wash already. There's 15 Newton. Okay, so we just go to multiply. So we get the answer. There's a 15 Newton. Okay, correct, T-Wash. I think you have finished the whole formative practice already, is it? Okay, so from here, we need to go to another one. Then should be B lah. Okay, question B. Okay, now the force is 10 Newton. Determine the displacement of the body 6 seconds after the body start to move from the rest. Start from the rest. So understood U equal to 0. Okay, then after that, the 6 second time taken should be 6 seconds. Then they call you to determine the displacement of the body. So from here, we know the F is a 10 Newton. Okay, from this one situation, you want to find displacement. Okay, we must using the 4 equation. Remember the 4 equation we learned in chapter 2.1, linear motion. Okay, so from there we need to apply that formula to find the displacement. The problem is I not enough information. I just got time taken, then I just got u. U is a rest. Final velocity I don't know. Time taken I also don't know. Acceleration I also don't know. So from here, the question give you force. That means this one force can help you to find acceleration because the question already got mass. Okay, so we go to see some info first. Okay, info is 5 kg, U is 0, then the force is 10 Newton, time taken, oh, got time taken, 6. Okay, S, what is the S? So from here, you also not enough because you got U, you got T, but you don't have V or A. So at least you want to apply the 4 equation, you must have at least three physical quantities. Okay, so from here we can find the A lah because they give you the force Z. So we apply the formula F equal ma first, we find the A. Okay, from here we get the A, that means we can apply the 4 equation. Okay, let's see. We just put 10. After this one, 5. So we get it, acceleration is a 2. Okay, now I can apply the 2 for the equation. Okay, remember the equation what we learned before. Okay, this one equation I want to find is a S. Okay, it's a S. So I got U, then I got T, then I got A. Okay, I want to find S. That means no V. Okay, you're going to think about that. Equation 1 until equation 4, which one is no V? No final velocity. Okay, so from there we get it. There's a number 3. Number 3 equation. There's a S equal ut plus 1 over 2 at square. Okay, that one is no V. So we go and apply S equal UT plus 1 over 2 AT squared. Okay, UT suppose we can cancel because U is a 0. So we just put, okay, S equals 0, 1 over 2. Then the A is 2. Then after that, 6, I need to square. Okay, so the final answer for displacement, there's a 36 meter. Okay, so from here, this one is until 2.6. Okay, hopefully the three formative practice can help you to check the answer. The wedge, how come is a 360? Is it my calculation got problem? Okay, suppose half and 2, this one can cut, is it? 2 and 2 we can cut, then the 6 go to square. Yeah, correct. That's a 36 meter. Okay, yeah? So from here, okay, we still got number 2. Okay, we still got number 2. Just now is number 1, number 2. Okay, now the force is 80 Newton act on a stationary object. Okay, stationary object. So from here we go to check. Okay, stationary object. Okay, understand. Okay, so from here the 80 Newton act on a stationary object for 7 seconds. So you can write the info lah. Okay, U equal 0. Okay, after that the time taken is 7 seconds and causes the object to reach the velocity 35. Means this one is a final velocity. Okay, so we need to calculate first one, the mass of the object. Okay, the mass of the object, you need to using the formula F equal ma. Is it? But the problem here, we don't know what is a. Agree. So we're still using the equation. So we write the info first. Okay, for the question A, we find the info. Okay, info is a 80 Newton. U is a 0. V is a 35. Then the time taken is a 7. They want to find mass. So what we need to do, we need to apply the equation to find what's the A first. Okay, UVT, you want to find A, is it? Okay, from here, they never mention S. No S is what equation? Okay, no S, I think the equation should be number 1. Number 1 is no S. Okay, let's see number 1. Okay, to find the acceleration, use the first equation. So the first equation is a V equal U plus AT. Okay, the wedge give me answer 16 kilograms. Okay, we go to check. We find the A first. Okay, so from here 35 equals 0 plus A7. So I find it the A should be 5 ms negative 2. Okay, so I go to using the 5 ms negative 2, apply for this formula. So from here then should be 80 equal m over 5. M multiply 5. Okay, after that 80 must over the 5 lah. So from here we get it 16 kilograms. Okay, that's correct. Then we go through the second one, displacement of the object. Okay, displacement of the object. Okay, let's see the displacement of the object. The info should be the same. Okay, one more thing to tell you. Normally, we want to find the displacement of the object. We do want to using the A, just now we find it. Okay, why? Okay, if I using the just now the A, I go to find it. If A is wrong, that means the following question is wrong. Okay, unless you cannot think anything already. You just got A information. Okay, then we just apply. So from here, I assume I do know the A. I using the U, V, and T. I want to find the S. So from here, you think about that. Which one equation is no A? No A, the equation should be number 2. Okay, now we go to check. Okay, to find the acceleration, we're using the second equation. Okay, the second equation is this one. S equal V plus U divided by 2 multiply with the T. So I go to apply 35. V plus U is 35. Okay, divide by 2. Then I multiply with 7. 7 is a time taken. So the final answer is 122.5 meter. Okay, let's say example, you say, I don't want using this all thing. I using the just now acceleration or not? Can. You can apply. Then the answer should be the same if your acceleration is correct answer. Okay, you can try. You can try it. Okay, after that, you can get the displacement should be the same answer. Okay, just a one clue want to share with you. If you are do wrong for acceleration, the following should be wrong. Okay, because we can using other way. Okay, beside using the acceleration, we can find the answer also. Okay, if you cannot think already, you just can using acceleration only, then we just use it. Okay, so this one is a one of the tips say to share with you lah. Okay, so that means I think this one is the 2.7, is it? So 2.7 I will continue to post to upload here about the impulsive force, the formative practice answer. So hopefully the student, yeah, you like my channel and you like what I share to you for this physics question or physics lesson. So from my channel got so many physics lesson you can refer there. Okay, impulsive force, I think the notes and also tutorial I upload already, so you can go there and refer it. All the notes and tutorial I already put in the description. Actually they can download. After you download, you can finish it. After that you can check your answer. Okay, so this one is what can I share with you all. So thank you to all the students. Okay, just thank you everyone. Okay, thank you. Bye.